By the late 1940s, the Sugarloaf Dam and its impoundment had served Victoria well, regulating the Goulburn for irrigation and turning those releases into clean energy. For 2 decades, it had underpinned farm security and added valuable generation to the state grid. But the problem wasn't the dam's integrity, it was its size. What had seemed ample in 1929 could no longer carry the Goulburn irrigation districts through extended drought years. Post-war Victoria was in an infrastructure boom. Population was surging, agricultural output was rising, and the State Rivers and Water Supply Commission was under pressure to deliver water security for new irrigation settlements stretching from Shepparton to Rochester. At the same time, the State Electricity Commission, riding the legacy of Monash, sought new generating capacity to support factories, housing estates, and a society hungry for power. Both agencies turned to the same valley and saw the same opportunity. Sugarloaf had been a pioneering step, but it was now too small. In the late 1940s, engineers reviewed the numbers. Their calculations were compelling. If the wall were raised and the upstream valleys flooded, the Eildon Valley could store almost 9 times more water than the original dam. The benefits went well beyond irrigation. Greater flood control would protect downstream towns, while improved drought resilience would secure crops across the northern plains. On the energy side, the increase in hydraulic head and controlled releases could deliver a major lift in hydroelectric capability. For policymakers, it was an irresistible combination. More food, more power, more security. The decision was made. Build a new embankment directly over the old Sugarloaf Dam, submerging it permanently. The original earthen fill structure with its concrete core would remain in place, quietly forming part of the new dam's foundation. In engineering terms, it was a bold move, not demolishing the old, but burying it, entombing a 1920s wall within a 1950s giant. Construction began in 1951. The design called for an earth and rockfill embankment 84 metres high at its tallest point and roughly 1,300 metres across, including its spillway. Its heart was an impervious clay core, a continuous vertical wall of watertight material keyed deep into the foundations. On either side, graded gravel filters formed defensive layers to capture any migrating fines, while massive shells of rockfill provided the bulk and stability. Each zone had a distinct function, together creating a dam wall that was both strong and resilient. This was dam building on a scale Victoria had never seen. Earth-moving fleets were mobilised like armies. Mechanical scrapers scoured borrow pits. Bulldozers pushed clay into stockpiles, and fleets of trucks hauled millions of cubic metres of material. The impervious clay core was placed in carefully watered layers, each one compacted by rollers to achieve the right density. Rock was quarried from nearby ridges, broken to size, and tipped into place to form the outer shoulders. Each layer was tested, surveyed, and signed off before the next went down. Piezometers, embedded deep within the fill, tracked pore pressures to ensure the structure was consolidating safely. The upstream face was protected with riprap. A large machine placed rock armour to resist the waves of the new, vast lake. The downstream face, steep and long, was trimmed, topsoiled, and seeded with grass to bind the slope against erosion. On the left abutment, a new gated spillway was cut into bedrock. Unlike the uncontrolled bywash at Sugarloaf, this was a precision instrument. Wide bays, controlled by vertical slide gates, each lifted by hydraulic hoists. The operators could now pass floods with exact control, lowering gates to hold water or raising them to release flows. It was flood management by design, not by chance. At the base of the wall, new concrete outlet works were built. These would feed both irrigation releases and the powerhouse. Here, steel penstocks carried water to the turbine hall, where the Eildon power station took shape. Two giant Francis turbines, each rated at roughly 60 megawatts, were installed side by side. They were fed directly from the reservoir, turning irrigation releases into electricity before the water rejoined the river. Together, they provide 120 megawatts of capacity, 8 times the output of the old 15 megawatt Sugarloaf station. It was renewable power scaled up to match the post war economy. But power generation was still tied to irrigation schedules. In summer, when farmers demanded water, the turbines spun hardest. In winter, they idled, with generation falling to a fraction. To solve the problem of fluctuating flows, engineers added another vital structure, the Eildon Pondage. Formed by its own smaller earthfill embankment downstream, the pondage acted as a regulating basin. Water released from the turbines entered the pondage first, where it could be smoothed and re-released steadily into the Goulburn. Vertical gates in the outlet structure allowed fine adjustments of flows, ensuring downstream users saw a steady river rather than the peaks and troughs of turbine operations. The construction was a mammoth logistical task. Borrow pits had to be carefully managed, with clays tested in laboratories for plasticity and permeability. Gravel was graded in crushing plants before being sent to site. Each shift of workers included surveyors, geotechnical staff, machine operators, and gangs of labourers. Camps were built on the hillsides to house thousands, complete with mess halls, medical posts, and recreation huts. For many of the men, including returned servicemen seeking steady employment, it was grueling but reliable work. The scale of social impact was no less dramatic. Farms were compulsorily required, and some protested bitterly, though most accepted compensation in the name of progress. Forests were felled, roads and bridges cut off, and whole landscapes erased. The human cost of water security was paid in memories and homesteads, now lying silent beneath Eildon's surface. Politically, the expansion was sold as the fulfillment of earlier promises. The closer settlement schemes and soldier settlement programs after both World Wars had promised returning servicemen a secure livelihood on the land. These farms couldn't survive without reliable irrigation, and Lake Eildon became the linchpin of that vision. Ministers hailed it as the answer to drought, and agricultural planners tied it directly to Victoria's reputation as the food bowl of the nation. The electricity it generated was almost treated as a bonus, though in reality, it was a vital part of meeting the explosive growth of households and industrial demand in the 1950s. By 1955, the transformation was complete. Storage leapt from 377 gigalitres to 3,390 gigalitres. The new lake stretched deep into the valleys, a vast inland sea that permanently submerged its predecessor. Sugarloaf, once the pride of Victoria, was now a foundation stone in something greater. The social and economic impact was immediate. Irrigators gained water security unmatched in the state's history. Dairy herds in Shepparton, orchards in Kyabram, and vineyards along the valley could plan with confidence. Victoria's food bowl had water on tap, regulated by storage that dwarfed anything before it. At the same time, the SEC could point to a new flagship hydro station, its turbines feeding power into the expanding state grid, just as demand for electricity was doubling every decade. For government, it was a model project. Jobs created, food secured, energy delivered. Few visitors today realise that beneath Lake Eildon lies a complete dam wall from another era, still performing a hidden role as essentially a cofferdam for the structure that replaced it. The 1950s expansion merged two generations of engineering, the compact, multi-purpose hydro schemes of the interwar years and the massive earth and rockfill projects of the post-war boom. It was, in a sense, the handover from Monash's vision to a new generation of large-scale state works. In the next episode, we'll look at how Lake Eildon's dual role, feeding farms and feeding the grid, is managed through the careful operation of both its water releases and its megawatts. I'm Paul Michael Angus. Thanks for watching.